All right, good afternoon. I'm really happy there's people inside because the weather outside is awesome. I think TechEd is the perfect excuse to get all the geeks out of their basement and into the sun, so the Microsoft geeks actually look happy and healthy when they come outside. So thank you for being here. Session of today, or from this time slot, will be about MyGet, which is a software as a service thingy me and my co-founder have been building during the past 2 years. And we've been building that thing on top of Windows Azure, and we've seen a lot of crazy things happening, both on the platform, both in our codes. We actually didn't even think this was going to be a viable product, so we actually didn't start building this thing with a monetization strategy in mind. So this talk is basically our war story of the last 2 years. Who am I? I am Maarten Baljouw, and during the daytime I work as a technical evangelist for JetBrains. And at night, I work on MyGet. In Belgium, I also am a board member of the Windows Azure user group, and my main focus is on everything web-related. So that's my main interest. Although Windows Azure is also a perfect platform to host your website, host your web application, and build your web application. So Windows Azure is also one of my big passions nowadays. You can find my blog on the slide. You can find my Twitter handle if you want to buy me a beer. Either buy me a beer or buy the book over there, which is on NuGet. So let's get started. The agenda for today, we'll first cover a bit what NuGet and what MyGet is, just so everyone is up to speed with what we are actually doing and to get a feel for the workloads we have in the application and so on. Next thing, we'll have a look at how we started and how our code looked like initially. All the pitfalls we encountered, what we did not know would happen during building this application. We'll have a look at our first architecture, then we'll have a look at our second one, which already implies our first one wasn't that awesome. We'll also have a look at multi-tenancy. That's a big part of MyGet nowadays, the multi-tenant aspect where enterprise customers actually can have their own version of MyGet, which is the same code base, but we want to make it multi-tenants. We've also had some tough times, and I'll quickly cover some of the tough times we had, because those are typically also learning moments. If you have a massive downtime or something really fails, those are the typical learning moments you have there. And we'll also have a look at how business may influence technology when building a solution like this. So let's get started. Who of you is a developer? Okay, everyone. Who of you has been using NuGet? Okay, all of you, so you probably know this. Who didn't use NuGet? Okay, one guy, two guys, thank you. So NuGet is an extension for Visual Studio, which you can use to download software dependencies that you need in your project. So typically, imagine you're building a web application and you want to make use of Elma, a popular logging and tracing framework you get for ASP.NET. If you want to install it without NuGet, you typically go to Google, you search for Elma, you try and find the latest binaries that are there. You will notice that you actually have to download a couple of binaries because maybe you want to write to an XML file, maybe you want to write to the event store, or something like that, so you'll have to find a couple of assemblies there. You'll have to extract them on your system, reference them in the project, add some configuration entries to your web config, which will probably fail because the documentation was outdated, and so on and so on. So you feel there's a big pain in adding things there. Microsoft Solved is actually pretty good with NuGet, which is an extension manager, which you can see on screen, and you typically just open it, search for Elma, click the install button, and this thing will bring down all the binaries. It will make sure that all the web config changes have been done and so on, which is awesome. This is a huge time saver, especially if you have a lot of external dependencies in your project. Now, there's one thing which is not that nice. Well, it is actually nice, but not always nice. All those packages you see in NuGet, currently about 40,000 the last time I checked, or 50,000 even. That's a lot of packages, and they are all on a public gallery, which means, well, you can create your own packages, but you probably do not want to add your own packages to this online NuGet gallery. Well, you may want to do this if you have an open source project or you're building an SDK for your consumers to use. But if you have some internal frameworks, for example, or some things you want to keep inside of your development team, you probably don't want to host them on the public gallery because then everyone can use them who has this extension manager. So that's why we came up with MyGet. which is basically a NuGet feed as a service. So you can just go there, create an account, create your first feed, start adding packages either from NuGet, from your TeamCity server, your own packages that you upload, and so on. We also have build services where you can just link your GitHub or Codeplex or Bitbucket repository, and we will do the builds for your package, and we will try to convert the source code into a compiled assembly packaged in a NuGet package on your feed. There's a lot of other things there as well. So, well, we have build services. We also have additional security. So a feed is owned by the feed owner, and you can have other people contributing to this feed. So other people may contribute packages to this feed. Maybe some team members can consume packages from this feed, but not add their own packages to it. Well, you can also configure that thing. So we have quite granular security there, which you typically find in a development team. We have activity streams, so you can basically see whatever every team member has been doing on this feed. So if someone created a package or deleted a package, you will see this in the activity stream as well. We have a symbol server, which means if you create a package and you also create a symbols package, which typically contains all the debugging symbols for your package, you can just upload both of them to MyGet, and in Visual Studio, when consuming your package and opening the debugger, we will also download that from our symbol server, so you can actually debug into the symbols for that package. And of course, a lot of analytics, so you can see who downloaded what, when, with which version of NuGet are they using, how many times does your CI build server, for example, contact the feed and download packages from there. So there's a lot of information you can get out of MyGet there. I'm not building this alone. So as I said, I have my co-founder, Xavier, and we also have Yves helping out on some features we have, so you can find them on Twitter as well. Or if you want to follow us all, you can just follow the MyGet team on Twitter as well. So how we started. As I already said, we didn't really start with a big idea in mind. This is actually the initial seed of MyGet. So I was blogging, and I was seeing that WCF was not really multi-tenant, and ASP.NET MVC was kind of popular, and they had routing and so on. So I decided to write a blog post on how to link different routes in ASP.NET to a WCF service, so you could actually have multiple endpoints all pointing to the exact same service in the back, and you could use route data to get, for example, values from the URL there. Now, a week after that blog post, I think, Microsoft introduced NuPack, which was the former name of NuGet. Well, one of the former names of NuGet, if you followed it from the beginning. And they were using OData as their feed. So if you are contacting the gallery, which lives on NuGet.org, and you consume packages from there, you're actually making use of an OData feed. And OData, in the implementation Microsoft has for that on the server side, is some kind of a WCF service. And having done that blog post, I was like, okay, maybe I can try and link this routing blog post also to WCF data services on which you can expose OData on your server. And I exchanged some ideas with Xavier, and during a conference in Belgium, we quickly prototyped something, and almost a week later, we had our prototype online. So we've been busy for the last 2 years. Initially, still no monetization strategy. We just put it online, and it was not doing a lot of things. You could just create your own feed and add your own favorite packages to those feeds, which you can still do, but that's only a really minor feature we have today. Again, we didn't think about marketing this. We didn't think about getting revenue out of this, so we just put it online to see if people would like it and would start using it. What technologies did we use to build this thing? Well, we used Windows Azure. Again, 2 years ago, that was kind of popular and hip in the world. So we were like, okay, we're going for Windows Azure there. Let's build it on top of Windows Azure. We also decided to not use SQL Server or SQL Azure to host our data. We decided to go with table storage, which is a storage service you have on Windows Azure. Why did we make this decision? I like to say that we chose this because of the fact that SQL Azure was more expensive than table storage. But building prototypes and so on, we were just like, we're doing NoSQL. Yay, we're hipsters. So that's why we chose table storage. We also decided to go with Windows Azure ACS to handle all authentication. So we decided to go with all social identities like Windows Live ID, Facebook, and so on. Reason for that, you're all developers, right? Who of you has never, ever built a registration and login system? One guy, congratulations. Everyone else has done this, and this was the last thing we wanted to do, so we decided to go with ACS again and not build our own registration system. Back then, MVC2, and we used Managed Extensibility Framework to have some form of dependency injection in there. I'll give you some codes we wrote back then, and you will see a lot of things there. So for example, this one, this comes from a controller. And you see when we are listing our feeds, we are simply just connecting to table storage and getting all entities from table storage directly in the controller. No repositories, no services, just connecting to table storage immediately. Which also means that throughout the code back then, we had a lot of these little things where we did some querying on top of table storage, but they were really scattered. So if we needed to fetch all feeds that were visible at the time, we would have this code on 30 locations in our code base. So no best practices being used there. This one's also an interesting one. I actually went through our source code we had 2 years ago. So we have a brilliant way of doing exception handling. We are not logging. The good thing about this one, during refactoring, by the way, was that we were consistent in doing things like this. So we simply had to do a find and replace for all omnom-noms, and we found all these cases. But best practices used, well, not really. Not really. The architecture at the data center level, well, we were using cloud services with just one web role doing all the work. The web role hosting the web application, and we did have some backend services. Back then, we were also mirroring NuGet.org because it was still only 1,000 packages, and that was still easy to do. So we had one background process doing that as well. Storage, we were hosted on one storage account, and we were, of course, using Windows Azure Access Control Service there. Now, what we did not know building this solution was that users would come. Initially, when we blogged about our prototype being online, people started using it. But the people who started using it were the direct colleagues who were on Twitter, the friends you see on Twitter, and so on. But after a couple of days, people actually started using this and adding their own favorite packages to MyGet. So a lot of feeds were being created, and our code base was not really ready for this. Also, data would come. Actually, one of the first big users of MyGet was the .spatial open source library, and they have a lot of really humongous NuGet packages containing all geospatial calculation metrics and some data to combine with that and so on. So they decided to use MyGet for their CI purposes, and whenever they created a nightly build or just a CI build during the day, they would push it up to MyGet, which meant after 2 or 3 days, we had 1,300 packages they submitted to MyGet, worth 1 gigabyte of storage. And again, our code base was not really ready for this. So that was interesting. Data would come. So, resharper time, we started refactoring and basically came up with a decent architecture to host our application. So we did a lot of refactoring. The direct data access we had in our controllers was quickly replaced by repositories and services with caching on them and so on. So we were actually making decent use of solid and dry principles to just have everything on one location, every class with one responsibility and so on. Using repositories, using services in the controllers, so a service could combine several repositories to do its thing. And we also scaled up from 1 instance to 2 instances for availability reasons. We also became a startup. Actually, the guy who is still writing code sometimes, Yves, he tweeted, "Why are you not making this thing a startup? Because a lot of people seem to like it." And we were like, yeah, maybe this guy is right. So we started to think about a business model, and while thinking about this business model, the volume of feeds and packages also kept going up. And we saw there were a lot of users spread across the globe, so in both Europe and the US, making use of MyGet. So we came up with this first architecture based on where our users were, what our business model might look like, and it looked like this. At the code level, solution level, we have a couple of projects all nicely separated in layers. So we have the web application sitting in a web layer, some services containing repository usage. We had repositories there. We had a myget.core, which was basically the garbage bin in which everything that didn't really fit in one of the other layers would go in. We had a myget.data, so we nicely abstracted our data access layer as well, and still one storage account accessed by this data layer. Awesome. Best practices being used. We had services, we had repositories, we had layers. Layers are good, right? If you're building an application, the more layers you have, the better. Talk to any architect, they will tell you more layers is better. So we were awesome. A typical business application architecture. A lot of applications you see in a lot of businesses are built like this. A lot of layers there, nice separation of everything that is in there. But it didn't really prove to be that awesome. Best practices, are they really best practices to split everything up in these layers in separate projects? To do mapping between entities and domain objects and then view models 3 times in your entire code? Why would you do this? Are they really best practices? Layers, do you need them? We didn't create spaghetti code, but instead we just created lasagna, just layers, layer after layer. And this typical business application architecture we had in place proved to be very inflexible. Again, are they best practices? Probably yes, but this thing slowed us this slowed us down. So when we started introducing new features on top of this architecture, we were confronted with the fact that we had all these layers and we had to duplicate work to get things done in the code base. So quite inflexible. At the infrastructure level, we were quite smart and we were hosting in 2 data centers. So in Europe West, which is our main location, and that's still our main location today, we had one web role running with a Windows Azure load balancer in front of it, which is awesome. One web server or one web role with a load balancer on top of that. And storage was there as well. In the US, we also hosted one web role in a data center, and we put Windows Azure Traffic Manager on top of that. Windows Azure Traffic Manager is quite an interesting technology. It's DNS-based round-robin load balancing or geo-redundancy or however you want to configure this. In our case, we chose to geographically distribute traffic using Windows Azure Traffic Manager, which means users from the US go to the US data center, users from Europe go to the European data center. If one of both locations would be down for some reason, we expected Windows Azure Traffic Manager to fail over to the other one, and it actually did that. Then we were also using the Windows Azure CDN to host all packages. So one of the things you want to do is, well, that's the main workload we see at myget, is downloading and consuming packages, either on a build server, either on a developer's machine. You just fetch packages from a feed. So we decided let's put those on the CDN. So all packages are closer to the user and they can download with lower latency and higher speeds there. And then ACS, of course, also in Europe West. Awesome. Data centers nearby our users. So users from the US would go to the US data center. In the EU, you would go to the European data center. Centralized storage, which was a great idea because you didn't have to think about replicating data to the US and so on. Packages on the CDN, fast throughput, close to the users, users happy, yes. And DNS failover in case one of the data centers went down, which was kind of easy because if we did a rolling upgrade of that one web role, we were down because we only had one instance there. So we relied on Traffic Manager to fail over to the other data center in that case, which also seemed to work. Now, data centers nearby our users, well, are they? We really don't know. We were not really tracking where our users were coming from, only the fact that they were from the US or from Europe. We didn't really look at the regions in Europe where they were, not at the regions in the US where they were, so we were not really sure the data centers actually were near to our users. This centralized storage was kind of slow. So if someone decided to manage his feeds from the US-based server, all the data and all the calls to our data layer would go over the Atlantic Ocean and speed of light. Even though it sounds fast, it is not fast if you have a lot of read and write operations going on during a request you have there. Also, packages on the CDN, well, that proved to backfire. The CDN was not that stable back then. Every now and then, packages would not be replicated to the CDN, even though we expected them to replicate to the CDN. The CDN had some downtimes back then and so on, so we decided to not go with the CDN anymore. Also, this DNS failover, that seemed interesting. So in Traffic Manager, what you can do is set the time to live for your DNS records. And we changed that to, I think, 15 seconds back then. So we decided if for 15 seconds one machine fails, it will just fail over and the DNS will point to the other location, right? Unfortunately, not all ISPs on this planet play nice with DNS. A lot of them cache quite longer is quite an understatement, but they keep quite an amount of caching of those DNS records, not respecting the time to live, which meant for a lot of ISPs, and typically the big ISPs in the US, some big ones in Europe as well, they basically made sure that our website was down for our users if we had this failover happening. So wasn't that ideal. However, we persisted and we tried to optimize our architecture a little bit. We added caching in the US. Main issue was slow page speeds. I think if you had a feed with 10 packages, which is almost nothing, it would take up to 10 seconds to show that page with all your packages. So that was quite unacceptable. So we decided to cache all that data in the US, and we were just replicating all data to a read-only copy in the US. So in the US, the server could actually retrieve data quite fast from the local copy sitting there. We also scaled out. We went to 2 instances in Europe, still 1 in the US. Main reason for that was this traffic manager thingy. If the US would fail, okay, so what? The US would be down. Those ISPs that respected the failover would fail over to Europe. Those who didn't, early stages, right? So you keep, you make those compromises. However, after these optimizations, we still were seeing that data synchronization kept being slow. When users were managing their feeds, we saw that they were actually doing a lot of operations which were still writing in Europe, and that kept being slow. It was no longer 10 seconds, but even 3 seconds for a simple management task like adding or deleting a package. That's quite long. Also, populating this cache was a nightmare. We didn't really have a good mechanism of knowing when we should be replicating data from one site to the other site. We had stale cache, we had data that was not in cache, so a lot of cache misses, and we didn't know when it would go stale, so we had a lot of caching issues there. CDN also kept having issues, and of the 3 instances we were running back then, so 2 in Europe, 1 in the US, if we looked at the CPU percentage and the memory usage of those machines, well, only 1 was actually being used for about 60%. Spread across those 3, of course, but only 1 was being used. So we were paying 3 machines and only using 1, to be honest. So we were thinking, okay, this cloud thing is all about pay for what you use, and we're not using and we're still paying. So what's the catch there? We also were growing. So we came up with this business model of having freemium feeds where you could just on board start for free. And if you wanted to have private feeds, you would pay for those feeds to be added to your subscription. We also added enterprise tenants. So enterprise tenants are basically MyGet, the entire copy of MyGet for your enterprise. So you will get a separate domain name and you will find your own logo on there and you can manage your own users and so on. So subscription plans, enterprise tenants who also had their subscriptions plans and so on. The architecture became quite complex. Also the caching and the synchronization we had just multiplied. We added more tenants, which means we have to add more caches and we have more synchronization and cache issues that we have there. So again, we decided to do some refactoring on the architecture. We looked at our workloads, and in MyGet there are basically 3 workloads. So we didn't really look at the code, we just started looking at the workloads. What are we actually doing with this product and what will users expect from this product? And one thing that happens, but doesn't happen that often, is managing feeds and packages. Every user typically does this once or twice a week or once a day or so on, but not continuously. It doesn't really matter where this was hosted, even though if we don't have the web application in the US, it wouldn't really matter that the users from the US would actually have to come to our European data center to do this management. It may add a little bit of a latency, but it's not that big of a latency in comparison with those caching and synchronization issues that we had previously. Second workload is downloading packages. So a lot of users use MyGit for CI purposes, and they are downloading packages on their build server like every 10 minutes, for example. So a lot of people are doing that, and we decided this is quite an important workload, so let's keep this data close to our users. Public MyGit websites, all packages are stored in West Europe. If you are an enterprise customer and you have your own domain name and you are in China, for example, we will make sure that your data is hosted in China, to have it close to you and to comply with all laws that exist around this thing. We also introduced build services where we would connect to your to your GitHub or Codeplex or Bitbucket repository. And that build server didn't really matter where this was hosted. So we could basically put it in the US or on a very cheap private server somewhere. So it didn't really matter because that thing is just fetching sources, creating packages, and uploading them to your MyGit feeds. So with that in mind, we came up with a new architecture at the infrastructure level. So still main data center Europe West, and we decided to go with 2 instances in Europe West, nicely behind the load balancer of Windows Azure. Those 2 instances would be using one storage account in which we have basically 2 types of data. Our tenant information, which domain name maps to which customer of the enterprise tenants and where is this storage account located, and some queues. I'll cover that one later. Then we also have Windows Azure Traffic Manager still in place, mapped to several data centers of Windows Azure. Although in those data centers we are not actively running any part of our source code. Reason why we did this is if Europe West would fail, we would still be able to quickly migrate to another data center, because the DNS level is the thing that will do the failover. So if we just deploy to Europe North or to the US whenever something fails in Europe West, we can get our website up and running in like 10 minutes. So it's just the uploads and the provisioning of this thing on Windows Azure, and we would be up and running without having to think about the DNS, because Windows Azure Traffic Manager would take care of the DNS there. Then per tenant, we have another storage account which contains the feeds, the users, the packages, and so on for that specific tenant. For the public MyGit tenant, everything is still in Europe West, but we do have some tenants who have a storage account closer to them, for example, in the US or in China. Then we also run backups. So Windows Azure, nice and fault tolerant and so on, but if I click delete, my data is gone. So I want to have a backup somewhere. Or not necessarily if I click delete, if our users click delete and they want their data restored, we can actually do that here. We do backups in Europe North in a different data center. Reason why is, well, if Europe West goes down and we have to come up, if it really goes down entirely, including storage and so on, not only compute, but also storage, we would be able to just restore a backup in a different data center, so we still have something to run. Even though the data may be stale, even though there may be packages missing, since we're not backing up continuously, we're just backing up daily. But we would still have something up and running, and our users would still have access to their packages until we were recovered in Europe West. Builds all running in Europe West, although again, it doesn't really matter. If one day Microsoft decides to take one of the older data centers and make the pricing much less in that data center, we would probably move build services there, because it doesn't really matter where we host this thing. We just want it to be hosted as cheaply as possible. With regards to code, you can see that we removed a lot of the lasagna there. We removed a lot of layers, and we basically came up with this MVC application, mygit.web, and our core infrastructure, in which we still had some layers. We still have some layers in there. We still have repositories and so on, but they are in the same project. Reason why? Less DLLs, less assemblies, and way easier to basically build the application. Our first architecture was scaled across the globe, so we had web servers in the US, we had web servers in Europe, but it was synchronous as hell. We had problems with caching, we had problems with latency, so if you would go to the US data center and would have to do a couple of writes in Europe, you would have to deal with the latency of that transatlantic connection. So our first architecture was really synchronous, and we decided to borrow some concepts from an event-driven architecture. Because back then, people were writing about this, and we were like, this does look like it could solve our problems with caching and so on. So we decided to borrow some concepts from an event-driven architecture there. We have some ground rules. If an action can be done at once, we just perform the action. If it can be done in one write, we just perform the action. If a certain action in the code, for example, changing a feed owner, for example, that's a lot of operations. If it's more than one operation, we typically put it on a queue. An I command, which is specific to that operation, we put it on a queue, and then on the other end, we have a worker running, which will process all those messages from this queue. Whenever an action, even those one-time thingies, whenever an action completes, also they will throw an event on this queue. So whenever I change a feed owner, after that completes, there will be an event on my queue saying that the change user for that feed completed. We can have handlers subscribing to those commands and to those events, and they will be able to execute the command or the event that has been thrown on the queue. One important thing, if you're doing this and you want to make use of commands and events and so on, you have to make sure all your handlers are idempotent, which means you want to be able to run every operation a couple of times without affecting your data. So, for example, imagine you're doing banking and you want to do something like a withdrawal of a bank account, and that operation fails a couple of times, and you process that message a couple of times again. You don't want to withdraw 5 times, for example, if you retry 5 times. You don't want to withdraw 5 times the amount that was actually supposed to be withdrawn. You only want to do that once. So make sure, even though something fails and you retry an operation and you rerun a command or an event handler, you want to make sure it doesn't screw up your data. So, for example, a login, that's actually an easy operation. It's just one read, checking the password in our data store, and one write to know when was the last time this user actually visited the website. No use of commands there, but we finish the operation with a user logged in event. So there can be a handler in our system monitoring this user logged in event, and based on that, it can trigger a different action in the code base. Changing a feed owner, that's quite a number of operations. You have to read 2 user profiles. The source user profile, the destination user profile. You have to make sure you know the current access rights. You have to change the access rights. Since our symbol server is not something we built, but something that the guys at Symbol Source are building, we have to push those new privileges to them as well. So a lot of operations, some integrations, a lot of work basically. So what we do there, if you want to change the feed owner, we fire a change feed owner command on top of this queue. Once that finishes, we fire a feed owner changed event on this queue. So how does this look like? We have our queue. We get our change feed owner command on the queue. We'll have a handler listening for that command, which will perform all the actions like reading user profiles, making sure that the feed is assigned to this new user. And once completed, we get a feed owner changed event in this queue. Again, we may have some handlers and maybe multiple handlers. For example, a symbol source handler, which listens for this feed owner changed event to synchronize with symbol source. We also have an activity log handler, making note, just a quick note of the fact that this feed owner changed and writing it into the data store. And then after those events or those handlers have finished their work, we again fire some events on this queue. Important thing, this is not a workflow. Everything happens asynchronously, and we don't want to enforce this flow. We do want to only change the data that is on symbol source whenever the feed owner actually changed, but we don't want to rely on the fact that that should happen all in order. So these handlers, they run asynchronously, they run in different processes. There's multiple handlers being run at the same time, so we don't want to rely on the fact that this event should have happened before we can do this thing. Again, idempotency, making sure that the events can be processed asynchronously and a couple of times. The gain of all this and of the architecture is that we now are able to run on 2 machines, mostly for redundancy. So looking at the load of our application, we typically run at 20% of loads on 2 small instances. So we don't pay that big amount of money to host MyGet. It's just 20% of CPU that we are using, and that is thanks to this new architecture. Also, this architecture made us way more flexible. Having all these events means that we can implement features quite quickly. For example, the activity log we have. So if you go to the website, you can actually see which user did what on your feed and so on. That was, I think the initial implementation of that feature only took 2 hours. We simply subscribe to the events, write everything in a store, and put a view on top of that. And that's basically it. So it is really easy to create new features based on this architecture. Storage, we're still not using a relational database. We are still using table storage. The reason why, not because it's NoSQL this time, but because we've grown used to it. It's not that expensive to use table storage. And if you have an event-driven architecture system in place where you simply store data a couple of times and have events create views for you that then can be used in your application, it's actually quite easy to work with table storage, even though you only have 2 indexes on every table. It's quite easy to do all that. Speaking of 2 indexes, we also came up with a brilliant solution to have a 3rd index on table storage, because you also have your table name. So for example, if we want to store all the packages for a specific feed, we have the feed name, which may be an index. We have the package ID, which may be an index, and we have the package version, which may be an index. Well, we need 3 indexes. We use 3 indexes. The feed name is just a table name. Every feed you make on MyGet has its separate table in table storage. Within that table, partition key is the package identifier, row key is the package version. So we can quickly query for one specific version of a package for a given feed because we have all those 3 indexes there. If we need more indexes, again, we simply duplicate our data and make sure we have an event in place, just storing the data a couple of times, specific for the view that will be used in the web application. Storage, well, we did some tricks there. Reading 1,000 rows from table storage is slow. And by slow, really slow. Not like a couple of milliseconds, but seconds. For example, if you have like 5,000 rows, you actually have to do 5 requests to table storage to get all this data, and it may take up to 12 or 13 seconds to do that. So we do some caching for specific tables. And one of those tables is the packages. Back to the example of this one open source project pushing a lot of packages. Back then they had 1,300 packages. I think today they will, I don't know, I didn't count them. But that's a lot of reads you have to do on table storage if you want to fetch those. So we cache that data. How do we cache this data? Well, not in a caching layer. We do not have a distributed cache in memory. Reason why? We would be wasting memory on our machines. We're only running on small instances, so we need all that memory to hold our working sets that we need in the software. So we don't want to pollute that memory with a distributed cache. We also don't want to go with a dedicated distributed cache because that would add cost to this solution. So we came up with the brilliant idea of just serializing all those packages into a JSON file, zipping it up and storing it on blob storage. Which means if you query your feed, we simply fetch that one blob from blob storage, fetch all those things, all those packages in memory, do an in-memory query, and give you the results. This is really, really fast to do, and again, dirt cheap to do. How do we update this cache? What happens if you push a package? Well, we fire an event on our queue. If that event is on the queue, we have a handler listening for this event, and it will simply update this cached version. If something really goes bad, we simply delete all the blobs containing caches, and all caches will be recreated. Multi-tenancy, another interesting part of what we've been building. How do you bring multi-tenancy in code? Well, initially we started with managed extensibility framework, but the fact that you cannot do nifty tricks with it like we do for our multi-tenancy moved us to AutoFac as a dependency injection container. So a tenant, basically, whenever you have a domain name and someone goes to the website on that domain name, you know you have a context. You are working in the context of a request response. There will probably be a user, and you have a tenant, which is also contextual. So you do those, and they may be different for every request coming in. But luckily, most DI containers, like AutoFac, for example, have lifetime. So this is what we do. We have an iTenant context, which we use in all our repositories and services. So if one of those things needs the tenant context, needs to know to which tenant this thing belongs, we simply query the tenant context. This tenant property there also contains a link to storage and so on. So whenever we have a request coming in on a different domain name, we know the tenant and the storage context for that specific request will already be mapped to a specific storage account. So we do that. We register our tenant context in our DI container, which is quite easy. We have this tenant context object for which we use the request tenant context object. And that thing simply checks the host name, fetches a tenant from our database or from our table storage, and uses that one in the DI container. Also makes it really easy to test because if we want to test our multi-tenancy, we can simply inject a different tenant context or some fake tenant context and run our tests on that. So really easy to do. Another thing that comes with multi-tenancy is access control. Imagine managing this in your own code base. You have multiple applications, you have a public-facing website, you have a staging, you have your local host, you have some customers running on that domain name, and they all have different identity providers. Some tenants may want to use Windows Live ID, Google, Facebook, Yahoo, and so on. Others may want to use their own ADFS server. Others may want to combine Google and their ADFS server and so on. So every application basically has different requirements with regards to which identity provider should be supported there. So what happens is you get spaghetti if you want to implement this yourself. So what we did was make use of ACS and all the identity orchestration that is in there. And I typically like to call ACS the BizTalk of identity, because it handles all the transitions, all the linking between the application and which identity provider should be used. So we have different domains, all mapping to different identity providers, and ACS orchestrates that part. So if we come in through myget.org, the application knows ACS, and we simply configured ACS as the identity provider for the application. Based on the incoming domain name, ACS will know which identity providers to show and which identity providers to allow logins in the application for all of those domains. So really easy to use. ACS for myget, well, we actually started using this because we didn't want to invent yet another registration system. And it's also quite easy to just work with ACS. You only have to add one trust relationship in your code base to an identity provider, which is ACS in this case, and ACS will take care of the orchestration of which domain name maps to which identity provider and so on. It comes with Microsoft accounts, it comes with Yahoo, it comes with Google, it comes with Facebook, and you can add your own identity providers if you want to do that. So at myget, we built identity providers for GitHub, for Stack Exchange, for Bitbucket, a number of them. And since they are in our code base and we want to get them out of our code base, we are actually working on a small spin-off, which is Social STS, on which you can actually use those identity providers with ACS as well. So if you want LinkedIn or Twitter, have a look at that one. It's basically the code we wanted to extract from myget into a separate service. We are also doing one small trick. If you're using ACS and you want to tell ACS which domain name you are, you typically add an audience and an audience restriction, which means that it works both ways. So the audience restriction works in this way that you're actually telling ACS which domain name you are hosted on and for which domain name you are accepting claims. By doing that, if someone with a bad intent wants to forge a login to the system, and they post back with a wrong domain name that is not known in the Windows Identity Foundation configuration, it will simply reject the token and not allow access to the application. Now, since we're doing multi-tenancy and since we do not want to change our web config every time we add a new customer in an enterprise plan, we're actually doing that dynamically, and we're simply using the federated configuration object there and adding the tenants on the fly at application startup and whenever we add a new tenant to the application. Then some tough times. We've had some really tough times with myget, or learning moments, depending on how you look at them. Typically, the moment they happen, they are tough times. Afterwards, they are the learning moments. Learning moments. We've had a huge downtime last year on July 2nd, which you can, by the way, read. You can read the entire log of what happens on our blog. We were seeing that users were complaining about downtime. On Twitter, we were receiving emails about downtime. They could not access their feeds, they could not manage their feed, and so on. We were not getting SMS alerts. We have monitoring on the website. If something really goes bad, we typically get text messages. This did not happen. Users complaining about downtime, but not getting SMS messages from the monitoring. After half an hour, trying to find out what was going on, trying to see, are those users, maybe it's the problem at the user side, or is it on our side? After half an hour, we were receiving text messages. Side up, side down, side up, side down, side up, side down, like in that pace. You can actually see I've added a small chart of pingdom, which we use to monitor this thing, and you see all those red lines in there. It was really up, down, up, down, up, down. So the text messages were being right. We then logged into the Windows Azure Management Portal, and we were seeing nothing. Everything was fine, everything was running, no real evidence of the fact that there was something going on in the website. So what's the cause? Well, this was shortly after we introduced our second architecture and shortly after we introduced multi-tenancy in there. So we were thinking, well, maybe we did, in fact, skip something and we missed something and we deployed a bug. So that would have been possible to be the case. We also just enabled storage analytics. That was also the time when on Windows Azure Storage, you could actually enable logging and some metrics. So you could see how many requests you were doing to storage, how much time it took to request a given blob or a table record, and so on. So we just enabled this thing, and we were thinking, okay, so either it's this multi-tenant architecture, or maybe it's this storage analytics that we just enabled. Because storage analytics is checking everything. It's writing to table storage as well. So we were thinking, this has just been introduced. Maybe we are just hitting throttles on Windows Azure Storage because of this storage monitoring. Also, Elma actually confirmed our suspicion that we were being throttled. So what is this throttling? Whenever you do a lot of requests to storage, Microsoft will try to slow you down and to make lesser requests, which is a bad thing if you have a running application because you cannot cope, well, storage does not cope with all your requests and you get some failures there. In our queue, we were also seeing a lot of unprocessed messages. So a lot of events, a lot of commands in this queue, and we were not really seeing a reason for why this would be the case. So, a lot of options about what could be wrong, and we actually found out what was wrong. So after 4 hours of debugging, diving into codes, trying to mimic what was happening on Windows Azure, we found that one simple piece of code, actually one line of code, brought down our entire application. Get hashcode. We did a crazy implementation, probably on a Saturday evening, of get hashcode for the package object. And whenever you would add a package with the same hashcode to a data context, which you are using if you're making use of table storage, then that data context will throw an exception stating that this package is already being tracked in the context and you should probably be doing an update instead of an insert. So get hashcode triggering exceptions in there. I'm not kidding you, we were being down because of an exception. Not because we were not catching those exceptions. We didn't have unhandled exceptions. We were simply catching any exception happening on the back end, so whenever an event or a command was there, and we had an exception, we just blindly retry the operation. Which means if you have 16,000 operations and commands in this queue, and they are being processed, they throw an exception, and they are being triggered again, they just keep triggering and keep adding new messages into this queue. So we were basically bringing ourselves to a halt because of this behavior, just simply retrying after every exception that happened. So all those commands were causing throttling, but since the website is also making use of storage and reading data from storage, the website was also being throttled. And if you're building a Windows Azure website or a web application on top of Windows Azure Storage and you are making use of the application blocks and you are also retrying your reads, you're actually making this problem worse. Because now not only our commands were making this throttling happen, but also our website was triggering this throttling behavior and actually making it even worse. Fun fact, the website kept getting requests from users and it would simply start retrying and retrying and retrying and retrying. Which meant we were simply starving IIS worker threads. So our website indeed was not down, it was just at 100% CPU all the time because of this behavior. So lessons learned there, don't implement your own get hashcode, that's the first. A simple bug can halt the entire application, by which I want to say if you are building a large-scale application, maybe having everything in one hosted service is not the best option. Maybe you want to have different deployments so that when something like this happens in one deployment, only part of your application goes down. Think about that when you're building your architecture. We were blindly retrying every exception because Microsoft was telling us you should retry if there's an exception in there. We were blindly doing that, but you only want to retry transient exceptions. So for example, when for some reason there's a small connection glitch between the website and storage, then you want to retry. If there's an exception coming from your data context, don't retry. Log it, put it on a dead letter queue, no matter what, but don't keep it in the queue and keep processing it. And don't retry the exception there. Our monitoring was also not the best. We did get some messages in the end, but because that thing was pinging our website, it just stayed while the website is up because it was up, only running at 100% CPU usage. So we improved our monitoring there as well. Also, we still had some leftovers in bad code, so this get hash code was actually one of the first things we ever wrote in the proof of concept phase of MyGet, so this thing killed our application. Then this year, we've also suffered a massive downtime on February 23rd. Who's running on Windows Azure? A couple of guys. Who was not down that day? Okay, so you probably know what this was. Everything was down. We were seeing our website was down, our application was down, storage was down. There was no failover happening at the DNS level. We saw furious users on social media and in our inbox saying, MyGet is down, MyGet is down. We also found the Windows Azure Management Portal down, and we saw some tweets being very negative on Windows Azure. So we were like, maybe this time it is not our fault. And what we saw was that Windows Azure was down at that moment. The reason why, Microsoft rolled out a certificate upgrade, which actually triggered a chain of events where the certificate upgrade failed, certificate expired, and basically if you were using SSL to connect to storage, you were in trouble because the certificate expired and your client SDK will not connect to a storage account which has an expired certificate. So that's what happened. Everything went down on Windows Azure. Not much we could do about it. We couldn't even fail over to North Europe or to one of the other data centers because we couldn't do anything. So lessons learned there. Maybe we should have thought about moving our storage connection strings from HTTPS to HTTP. Now, looking back at that option we have there, we didn't decide to do this. Reason why we did not decide to do this was that we want to make sure that all the data transport within the Microsoft data center is secure at the transport level. So you want to keep that HTTPS certificate there. Another reason for not doing this is probably Microsoft will not pull that same stunt a second time. So probably this bug should never happen again. Who knows, but probably not. We also noticed that Windows Azure being down globally has quite an impact on our application. So what can you do if an entire cloud platform fails? Well, there's not much you can do. The only thing you can do is host a second deployment of your application on a secondary data center with another cloud provider, with a hoster, or in your own basement. Now, that's quite expensive to do. Duplicate everything, make sure that all the data is duplicated continuously between both locations. So that's actually quite difficult to do. And we decided against doing this because, again, we think Microsoft will not pull the same stunt twice there. We are, however, considering of moving our backups off Windows Azure. So now we are backing up on Windows Azure or on the North European data center. We are thinking about moving our backups off Windows Azure just to make sure in case this happens, we still have all the data. Another learning moment, new features. One of the first feature requests, I think, in our issue tracker, this was item number 7. And after 2 years, we decided to finally implement this one, retention policies. So whenever you have a CI feed, for example, you're just pushing your CI packages on top of MyGet, what we allow you to do is configure a retention policy where you can say, I only want to keep the latest 10 packages. Maybe you're not interested in all packages, maybe you just want the 10 latest that have been deployed to your feed. So we introduced this thing, and apparently it was a massive success. Like we send out the newsletter, and minutes thereafter, a lot of users started to enable those retention policies, typically on really highly loaded feeds. Now remember, deleting a package is actually a kind of complex given. So we have a command for that, which is dispatched to our queue, which is then processed in the background. So when people started doing this on a feed containing tens of thousands of packages, we would get a lot of messages in our queue. For every package on that feed, we would get a message in that queue. So a lot of people were complaining about the fact that their cache was not being updated. Well, our cache updates also go through the same queue, which means they were somewhere in between those delete commands that were sitting in the queue. So eventually it would get processed, but the cache was indeed stale. So solution to this, we simply scaled out. So going from 2 instances to 20 instances, we were actually able to cope with this thing in a couple of minutes. So keep in mind retention policies or new features in your application may actually cause some additional load on the application. What we learned from this is 2 things. We're still considering about having a secondary queue in which the high priority commands like updating the cache and so on would go. Although that feels kind of awkward to do, but we're still thinking about doing that. Another thing we are thinking about doing is if we again have big features where we expect a decent load on the application, we will probably start working with feature toggling, which means enabling the feature for a small subset of our users and gradually adding more users to this feature, just to prevent this massive rush on our queue to happen. But overall, we cannot complain, except for February, our uptimes have been going up, and I hope this month we will get our second month of 100%, and it looks good so far, so don't enable retention policies, thank you. So, when business meets technology, we are developers in our hearts and in our souls and whatever we start doing. And if you start working on something like MyGet and you start making it a business, you actually make a lot of failures. One of those failures is that you are continuously biting yourself. How cool is it if in the morning you think that would be an awesome feature? You start coding, you deploy the feature, you tweet about it, you put it on a blog post, and people start tweeting about it, and it gets successful. That's a bad thing to do, to be honest. It's good because you have this feature available, and you can get some buzz, and people will go to the website and so on. But how are you going to bill for this feature? How are you going to earn money on this feature? And if you start thinking about how you're going to do that, billing this feature, you typically come up with a revenue model, which may mean that you have to rewrite a feature. You may want to be adding metering in there. You may want to be adding some logging in there so you know how much this feature is being used so you can actually bill for this feature. And doing that afterwards typically means that you're adding a lot of code and rewriting a lot of code that by just thinking about this upfront would have been easier to do. And we've been doing this since the beginning. We've actually deployed MyGet like, yay, it's cool, we have WCF routing in there and multiple feeds and so on. And only after a year, we started thinking about revenue streams. So we had to do a lot of refactoring there. And still today, although we are learning, but still today when we have a new feature ID like build services, that's something we built in a couple of evenings, which is kind of popular, and we're still thinking about how we're going to monetize that thing. But if we are going to monetize that thing, we will have to do a lot of rewriting to make sure we can actually measure what's happening there. So lesson learned from this thing, think revenue first and then build a feature, because that will impact how your code will look like and how your development process will work. Another thing is measure everything and test your assumptions. So if you're reading any startup book, for example, the Lean Startup, it's an awesome book. Every startup book will tell you to measure everything and test your assumptions. Okay, so we did that. Now, don't build this thing yourself. We are actually trying to contribute a lot of the things that we are doing to the community. So we've built this Google Analytics tracker, which is a NuGet package you can install to basically measure everything using Google Analytics. Building your own monitoring system, building your own Google Analytics is a tedious effort, and you don't want to go there. Just simply use this one, link Google Analytics, and you know what's happening inside of your application. What are we measuring? A lot of things. We are measuring our users, all the traditional things coming in through Google Analytics, but we are also measuring feature usage. We're not measuring who is using what feature for which package. We're not looking at your data. We are simply interested in what feature is being used how often. So what we do is we log events in Google Analytics, and you see those features as the name of the event. So we have an event called feature in Google Analytics, and we fill it with a name which is the name of the feature. So the first thing you see there is the traditional login feature, which was actually being used quite often. This dates from a couple of months ago. So seeing this traditional login surface as the first item in Google Analytics meant that people were actually making use of their Visual Studio credentials for their NuGet feed to log into MyGet. So we had this login system where you could log in with username and password as well. And a lot of users were using this more than our actual features, apparently. So by seeing this, we were actually brought to the attention that we should probably be building another registration system after all. So we did that because of this thing. So now you can go to the website, register your account without using Google accounts or Facebook or Yahoo or whatever else is available because of this thing. Measure everything. Another item there is build services. That's actually the second thing. Again, that's still in beta. We still haven't decided how we are going to make a revenue out of build services, but we see a lot of people are using this thing. So it's popular. We can probably charge money for this one, and we must probably keep investing in building on this feature, making it better, adding new features to this feature, and so on, because it's in our top 5 of most used feature month after month. Another one, feed discovery. That's already 2 months ago, I think. We've introduced feed discovery. We've proposed this thing as a way of discovering NuGet feeds, much like you discover RSS feeds today. So the idea of feed discovery was that you could add a link to your NuGet repositories or to MyGet or to whatever feed you want to host your packages on to your website, and you could simply click on that website from within Visual Studio or trigger a command on that website from within Visual Studio, and package discovery or feed discovery would add all those feeds to your Visual Studio configuration, to your NuGet configuration, so you could actually consume those packages from those feeds. When we were writing that, we were thinking, okay, maybe some enterprise customers will be using this thing, but will not be that popular. We were proven wrong. Our assumption was this will not be used. The actual measurement shows that this is the third most popular feature month after month. So a lot of people are actually making use of this thing, and we should probably start lobbying to get this feature finally into NuGet Core. We've also built a feature which allows you to download all the packages from your feed in a zip file. So what you can do is just go to the website, log in, go to a specific feed, and if you want to create a backup or you just want to have an offline copy of all the packages on that feed, you can download a zip file and get that on your system. Now, when building this thing, we had a lot of requests from users asking for this feature, and we were thinking, okay, this is going to be our next retention policies. We will be grinding ourselves to a halt with this feature. A lot of people will start making backups and so on, and we were kind of scared of putting this feature online. However, measurements prove that this feature is almost not being used. So again, test your assumptions, measure everything. We were thinking this one would be popular, wasn't really popular. Package discovery, feed discovery, we were thinking people would not actually start using that one. Well, they actually started using that one. So measure everything and test your assumptions. With that, we've built an application. We didn't start with a revenue model at first. So if you want to build your own startup, if you want to build your own software as a service project, do think about revenue first and then start building it, not the other way around, because you're doing a lot of rework there. NuGet, an awesome tool to install software dependencies in your software projects that you are building. MyGet can help you host your intellectual property, user management, and so on. We started with no revenue model in mind. We started building this thing. We didn't really respect all the coding standards and quality standards that are available on the market today. And, we kind of killed ourselves there because a lot of people started using MyGet, and we did not know it was going to be popular, so we had to refactor. We had all these assumptions about how Windows Azure would work and multi-data centers spread across the globe, blah, blah, blah. We discovered there was latency there, so we decided, well, okay, it's time for another refactoring. We went to the second architecture. We added multi-tenancy. We are using ACS to do part of this multi-tenancy at the identity level. You will face tough times building your application. We've had a couple of those. It's been stable for a while, so let's hope nothing breaks today. But we've been very stable for a while. And those tough times provide learning moments. So whenever you have something like that, try to investigate to the bottom, try to investigate what happens, and try to learn of your failures there. For example, don't implement your own get hashcode methods. There's tools for that, code generation for that. Use those code generation tools. Measure everything. Measure everything. You will make assumptions. Whatever you do, whatever feature you create, you will be thinking this will be popular, a lot of people will use it, or no one will use it. Well, you are typically wrong. Users will do the exact opposite, and you have to measure what is happening to discover trends on what you should be building next. There's only 2 guys actually actively building MyGet currently, which is me and Xavier. By measuring these things, we know what feature to build next. We have a huge backlog. We have a lot of ideas to put in this project, but we want to make sure that what we built is actually going to be used, and that can be done by measuring everything. With that, thank you for being here. There's some related contents on designing cloud architectures. Real-world architectures is another one you can find on Channel 9 from TechEd US. I think the session is also being given here. And find me in the hallway, find me eating ice cream or drinking coffee. And if you want to talk about this or about Windows Azure in general, I'll be happy to have a chat. Thank you for being here. If you want to buy me a beer, buy me a beer. If you want to read the book, you can also read the book, and that will buy me half a beer. Thank you. Okay, so the question is, what's the final story about the CDN? We are not making use of the CDN. The CDN is still there, but it proved back then so unreliable that we decided not to try it again for now. Although we have heard rumors that something is coming there, and I would assume something is coming there as well. So maybe if there's a V2 of CDN, we will have a look again.